Okay, so let's have a quick look at some surds and how we can simplify and rationalize the denominator for surds. So the two rules that we use are that the square root of AB is the same as the square root of A multiplied by the square root of B. So we can split our roots up. And the same works with divide. The square root of a fraction is the same as the root of the top divided by the root of the bottom. We can use these rules when we simplify fractions. Mostly this top rule is the one that we use. So if I wanted to simplify something like, say, the square root of 12, what you're looking for when you're simplifying is any square numbers that go into 12. So the square numbers are 1, 4, 9, 25. So something squared. So I've spotted that 4 goes into root 12. So I'm going to write root 12 as root 4 times root 3. And then I know that root 4 is the same as 2. So my simplification of root 12 is 2 root 3. I could do the same if it was something like root 20 over 2. So again, I'm looking for square numbers that go into 20, and yet again I've noticed that it's 4. So I'm going to write that as root 4 times root 5 all over 2. I've spotted that root 4 is 2, so that's 2 root 5 over 2, and then I can cancel out these 2's. So the simplification of that one is just root 5. One last example, if we have something like the square root of 20 plus the square root of 80. What I'm trying to do here is get them both so that they have the same sort of root base. So start with 20, and we've done it above. I'm going to say that 20 must be root 4 times root 5, which is 2 root 5. And if I'm looking at 80, saying, well, what goes into 80? What square number do I know that goes into 80? And if you like, this root 5 gives you a hint. 80 divided by 5 is 16. Well, that's a square number. So let's write 18 as root 16 times root 5. And I know that root 16 is 4. So I've got 4 root 5. And 2 root 5 add 4 root 5 is 6 root 5's. So the rules for rationalizing the denominator then are that if you have 1 over root 2 and the bottom is just a root of something, then you multiply both the top and bottom by that same square root. And because we're timesing it by the same root, 1 times root 2 will give you root 2 on the top. But root 2 times root 2 will give you, you can either think of it as root 4 on the bottom, or that's the same as root 2 over 2. So 1 over root 2 with the rational denominator is root 2 over 2. It gets a little bit more complicated when we want to do something with a root minus or a root plus something in the bottom. So if I had 1 over, let's do 3 plus root 2, then the rule is what I times by, the bit here, I always do the opposite. So in this case, when I times the top and bottom, I'm going to multiply the top and bottom by 3 minus root 2. So the top line, pretty simple. 1 times 3 minus root 2 is just 3 minus root 2. And the bottom line becomes 3 plus root 2 times by 3 minus root 2. So the bottom line, if I multiply this out, 3 times 3 is 9. 3 times minus root 2 is minus 3 root 2. Then root 2 times the 3 is plus 3 root 2. And plus root 2 times a minus root 2 is minus root 4. Or if you like, that's the same as the number 2. If you can do that straight away in your head. So rationalize the denominator. The top is staying as 3 minus root 2. And if you've done this correctly, when you now look at the bottom, these bits here should always cancel out. That's why you've chosen one positive, one negative. So minus 3 root 2 plus 3 root 2 will give you 0. And 9 minus the square root of 4, well, the square root of 4 we know is 2. So 9 minus 2 gives us an answer of 7 on the bottom.